Here is the math problem we will solve today. Our goal is to find the exact value of x. We start with 5 to the power of x plus 1. Next, we subtract 5 to the power of x. This entire left side equals 100. We look at the first term of the equation. It is 5 raised to the power of x plus 1. We can use a basic rule of exponents here. When adding in the exponent, we can split it. We multiply the base with separate powers. So we write 5 to the x times 5 to the 1. 5 to the power of 1 is just simply 5. We can place this 5 in front of the term. This gives us 5 times 5 to the power x. Now we rewrite the original math equation. We have 5 times 5 to the x minus 5 to the x. This entire expression is equal to 100. We notice a common part in both of the terms. The expression 5 to the x appears twice. We can use a simple variable substitution now. Let us introduce the new variable called u. We will set u equal to 5 to the power of x. We must carefully define the domain for our new variable. The variable u represents an exponential math function. The base of this exponential function is a positive 5. A positive base raised to any real power remains positive. It can never become a negative number under any condition. It also can never evaluate to the number 0 itself. Therefore, the value of u must be strictly greater than 0. This is an important condition for our new variable u. We proceed knowing u is restricted to positive values. We substitute u back into our new math equation. The first term becomes 5 multiplied by u. The second term simply becomes our variable u. Now the equation reads 5u minus u equals 100. We need to simplify the left side of this equation. We can factor out the common variable u from both terms. We write u outside of a set of parentheses. Inside, we have 5 minus 1 from the coefficients. Now we perform the basic subtraction inside. 5 minus 1 gives us the integer 4. We replace the parentheses with the number 4, so we have u multiplied by 4 equals 100. This is exactly the same as for u equals 100. We want to isolate the variable u on the left side. To do this, we must divide both sides by 4. On the left, 4u divided by 4 gives exactly u. On the right side, we compute 100 divided by 4. Let us review the simple equation for u equals 100. We can use standard long division to find the final answer. We place 100 inside the basic division bracket. We place the divisor for outside of the division bracket. We look at the first digit of the number 100. The number 4 does not divide into the digit 1, so we consider the first two digits to form the number 10. We determine how many times 4 fits inside of 10. 4 multiplied by 2 gives the number 8. 4 multiplied by 3 gives the number 12. The number 12 is too large, so we must use 2. We write the digit 2 directly above the number 10. We subtract 8 from 10 to get a remainder of 2. We then bring down the final 0 from the 100. This creates a new working number of 20 at the bottom. We divide this new number 20 by the divisor 4. 4 multiplied by 5 is exactly equal to 20. We write the digit 5 next to the 2 on the top line. The subtraction leaves a final remainder of exactly 0. This perfectly confirms our division result of 25. Now we have found the exact value for our variable u. We determined that the variable u equals 25. We must remember that u was just a temporary substitute. Our true goal is to solve for the original variable x. Earlier, we defined u as 5 to the power of x. We will now substitute 5 to the x back in for u. This gives 5 to the x equals 25. We have an exponential equation to solve right now. The variable x is located far up in the exponent. We need a mathematical tool to bring the exponent down. Logarithms are the perfect tool for this exact job. We can take the natural logarithm of both sides. We apply the natural log to the left side expression. Then we apply the natural log to the right side value. The left side becomes the natural log of 5 to the x. The right side becomes the natural log of 25. Now we use a very powerful property of logarithms. This property is called the power rule for logarithms. It says an exponent inside a log can be easily moved. We can take the exponent and place it in the front. It becomes a coefficient multiplying the logarithm. In our specific case, the exponent is the variable x. We move the variable x to the front of the log. This gives x times the natural logarithm of 5. So x times the natural log of 5 equals log 25. We still need to isolate the variable x completely. The variable is multiplied by the natural log of 5. We undo this by dividing both sides by that exact amount. We divide the left side by the natural log of 5. We divide the right side by the natural log of 5. On the left, the natural logs cancel out completely. We are left with just the variable x on the left side. On the right, we have a fraction of 2 logarithms. It is the natural log of 25 over log of 5. We have x equals the natural log of 25 over log 5. This ratio of logarithms appears complicated at first glance. However, we can apply specific logarithm rules to reduce it. We focus entirely on the numerator of this large fraction. The numerator contains the number 25 inside the log. We search for a way to express 25 using a smaller base. We look at the denominator, which has a base of exactly 5. It is very helpful to match bases when simplifying fractions. We evaluate the prime factorization of the number 25. We can simplify this fraction to find a much cleaner number. Let us look closely at the numerator of the fraction. The numerator is the natural logarithm of 25. We recognize the number 25 is a perfect square. 25 is exactly equal to 5 multiplied by 5. We can rewrite 25 as 5 to the second power. Now we substitute this back into the numerator. The top becomes the natural log of 5 squared. We can apply the power rule of logarithms once again. The exponent of 2 can be moved to the very front. The numerator becomes 2 times the natural log of 5. Now we look at our entire fraction expression again. The top is 2 multiplied by the natural log of 5. The bottom is exactly the natural logarithm of 5. We see the natural log of 5 on the top and bottom. These identical terms will cancel each other out. We divide the top and the bottom by this shared value. This leaves us with just the number 2 remaining. Therefore, we have found that x is strictly equal to 2. We must verify our answer by checking it carefully. We will plug our value back into the initial equation. The original equation starts with 5 to the x plus 1. Then it subtracts 5 to the power of the variable x. We want to see if this truly equals 100. We substitute the number 2 for every x we see. The first exponent was the variable x plus 1. We replace the x with the number 2 in this exponent. The new exponent becomes 2 added to the number 1. We compute the simple sum of 2 and the number 1. 2 plus 1 gives us a final exponent of 3. So the first term becomes 5 to the third power. Now we evaluate the second term of the math equation. The second term was originally 5 to the power of x. We substitute the number 2 in place of the variable x. This term simply becomes 5 raised to the second power. Our equation now reads 5 cubed minus 5 squared. We will calculate the value of each term individually. Let us determine the exact value of 5 cubed first. 5 to the third power means multiplying 5 3 times. We write out 5 times 5 times 5 to calculate it. We multiply the first 2 5s to get 25. Then we multiply 25 by the remaining 5. This final multiplication gives us 125. So 5 to the third power equals 125. Next we evaluate the term 5 raised to the second power. 5 squared is just 5 multiplied by the number 5. This calculation gives us the result of 25. Now we return to our simplified subtraction expression. We replace 5 cubed with 125. We replace 5 squared with the value of 25. The expression is 125 minus 25. We perform the subtraction to find the final difference. Taking 25 away leaves exactly 100. This matches the right side of our initial equation. Both sides evaluate to the number 100 perfectly. Our solution has been completely and thoroughly verified. Thank you very much for watching this math problem today. Please like the video and subscribe to the channel.